Hello, and welcome to room 261. Um, this is the second day of the Law of Sines lesson. I'm actually recording this prior to teaching the first day, and so it's possible as you watch this, I would have already gotten to some of this in class. If so, I suppose you have a fast forward button on your calculator. But as mentioned the other day in class, the law of sines can be used when you know two angles and a side, but it's also true that it can be used when you know two sides and an angle, but it's a little trickier. And so, solving law of sines problems in the side angle case, you have to kind of be careful and try to figure out exactly how many triangles are possible given the information that you have. And so, we're going to start with actually the easiest one. And in this case, if angle A is obtuse and you know angle A and you know side A and side B, it's possible you'd have a triangle if side A is, bigger than side B. Because, if angle A is obtuse, then the side opposite A has to be the biggest side of the triangle. And so let's do a quick problem with this going on. And so I have a problem listed here, and it says solve triangle ABC if A is 112 and A is 16 and B is 6. I recommend drawing a picture. Doesn't have to be perfect. But let's say this is 112 degrees, this is A, and that would make this side 16. I like to make the side along the horizontal here B, and that would make this side C. And so by the law of sines, we know that the sine of A over A is equal to the sine of B over B. And so, we have three of those four things, and so therefore we can solve the proportion. And so the sine of 112 over 16 is the sine of angle B over 6. And so the sine of angle B is 6 times the sine of 112 degrees divided by 16. And so, let's just make sure we know how to use our calculator here. If we go to the calculator and we make sure we're in degree mode, okay, then we hit 6 times the sine of 112 and divide by 16. And that gives you the sine of B. Now remember, you want B, you want an angle, and so you need to hit the sine inverse button. And so it's 20.346 degrees. Now, you want to store this, and so you want to hit the store button here. I'll even move my calculator where you can see. You want to hit the store button, right above the on key, and then store it. You may as well store it in B, since that's what you found was angle B. And so there it is. And so we can write it down. B is about 20.3 degrees, but we're going to use the stored value when we go to find the other stuff if we need to. And so angle C is 180 minus B minus A. And so when we go to do that, we may as well just use the stored value on our calculator. So 180 minus B, and so you hit alpha B, minus 112, which was A. And so this is angle C. And so angle C is 47.6. Again, the recommendation here is to store it and hit stow alpha C and enter. Okay, now when you go to solve it, we say that the sine of C over little c is the sine, and you can pick either A or B, but A is cleaner because it's exactly 112 degrees over 16. And so little c is 16 sine C over sine 112. And so we get out our calculator, and we had just stored C there. And so let me try to get it where you can see everything. And so you want 16 sine C, so sine alpha C, divided by sine 112. And so you get this number here, about 12.8, I guess, or 12.754. A lot of times we round the sides to the nearest thousandth, and we round the angles to the nearest tenth. And so you might notice that I didn't need any inverse buttons, right? Because I was finding a side that time. When you find the angle, you need the inverse button. When you find the sides, you just type it in. Let me just show you. Had you not stored the value, and actually I just noticed that I rounded poorly. It was 47.7 when it was rounded. So let me write that down up there. And anyway, suppose you just sort of hit 16 sine 47.7 as opposed to the whole value of C, and then hit divided by sine 112. You get number pretty close. You get 12.763, but as you can guess, in room 261, that's not going to get you full credit. So you do want to make sure that you are using your storage buttons. Okay, let's move on to another case of the side angle stuff. And so in case 2, suppose you're given that angle A is obtuse, but you're told that A is less than B. And so this one might even be easier than the last one. And so as you can see from the picture, if you know that angle A is obtuse, and they told you that some side B is bigger than some side A, then there's just no way to make a triangle like that. And so when you go to do this problem, let me show you here. So let's say we have this one. And so again, we draw in this 112, and we put B over here to be 16. Well, if that length is 16, then 6 is only about that long, right? And so there's just no way to make this triangle. And so there's no solution to this triangle. So there's not a triangle out there that is such that there's an obtuse angle of 112 and the side opposite, the obtuse angle being smaller than the other one. Okay, let's move on. So in the next case, let's say that we have an acute angle. All right, so you can see in the picture that we have an acute angle A, and we're told that the side opposite A is larger than B. And so in that case, okay, again, this is easier. There's only one triangle that exists, and so we would go solve it. And I'm not necessarily going to solve a whole triangle in the interest of time here, but I'm gonna get you started. And so let's see, what was I looking for? That one. And so we have this situation here, and again, I would totally draw the picture, and I would always draw it kind of the same way. And so our angle A is this. I just like drawing this vertex on the right. Okay, whoops, I was doing the wrong one. There we go. And so angle A, I'm drawing this on the left at 62 degrees. And then B is 8, so I'm going to put B up here and A to be 17. And so that totally could happen. All right, that's totally a triangle that's possible. And so we could say that the sine of 62 over 17 is equal to the sine of B over 8. And then in a way that we're used to doing, then we cross multiply and divide. And so sine of B is 8 sine 62 over 17. And so we get out our calculator and we type in 8 sine 62 divided by 17, and we get this number. Now again, just like on the last one, we have to know whether we're trying to find an angle or a side. We're trying to find an angle here, and so we need to hit second sine. So sine inverse of that number, and we'll get that the angle is 24.6 degrees. Okay, and we'll store it. All right, and so we'll store it, and then I'm not going to finish this one like I did on the last one, but we'll store it, and you will use that angle to find C, angle C, and you'll go from there. And so you can see on my calculator that I just stored it in B. And so maybe I'll solve it. Actually, I told you I wasn't going to, but maybe I'll solve it without really writing a whole bunch of stuff down. A was 62, and so angle C would be this one. Okay, and then what we would end up getting is a proportion that would say that angle C, or times. How do I want to say this? So that's C, and so I said I wasn't going to solve it. Now I'm solving it. The sine of 62 over 17 would be the sine of C over C, but we have big C, and so little c is 17 times the sine of C, and then divided by the sine of 62. So maybe I won't write everything down, but you would get that for side C. Now, since it's a side, you don't need any inverse keys. Okay? All right. Now, another case is such that angle A is acute, and the side A they give you is smaller than B, but not only is it smaller than B, but it's smaller than this altitude. Okay, so it's smaller than B sine A. And so H is equal to B sine A. If you want, you could think sine A equals H over B. Again, sine A equals H over B. And so if that's the truth, then H would be equal to B times the sine of A. And so if you were given this situation, okay, you're told to solve a triangle here, and you have this, and you might not really notice it as you're looking at it that something is awry. But if this is 62 degrees, again, I would draw it every time, and I would draw it the same way. And let's say this is 17, and then it says A is 8, okay? And so 8 seems pretty small compared to 17, and so, it's probably not big enough, right, to make a whole triangle, and it's not. Because the length of this side here, call it H, as we did in the last problem, the sine of 62 is H over 17. And so H is the 17 times the sine of 62. If we took 17 times the sine of 62, we would get 15 approximately. And so you notice that if this distance here of H is 15, there's no way to make this triangle where that distance is 8. You could kind of think of swinging this 8 along here, but it's just not going to touch that horizontal side. And so there's no solution here. Okay. Now, suppose like you didn't draw the picture, right? And you were just kind of doing your homework and checking your social media and watching some TikTok videos and whatever, and you didn't draw the picture, and you'd set up this proportion. Now, what you would find is that you would try to set up this proportion, and I'll change that A to an 8. And then you would think, all right, sine of B is 17 times the sine of 62 divided by 8, right? And so if I took 17 times the sine of 62, which I just did actually, and then if I divided it by 8, you'll notice that it's above 1. And maybe then you would think, well, that's impossible to have the sine of an angle above 1, but maybe you hadn't had that thought. And maybe you hit second sign and hit answer. And now it's going to say, oops, error. And so hopefully at that point, you would say, whoops, maybe this is a no solution situation. And it is. Okay. And so in this case, when your calculator tells you to quit, it's okay. All right. Now, the one that's a little the trickiest, I guess, is the next one. And so in this case, what if the side they give you for A is in fact smaller than B, but yet bigger than that altitude we talked about? And so it can convince you, a little geometry can convince you that you've got two possible solutions here. And so let me give you another picture that really helps a little bit better with that. Where did I have the other picture? I had it ready, I thought. Maybe I just didn't, maybe I deleted it. Hang on a second. And so Oh, I just had it. There it is. And so, anyway, so like here you can see that side A in red is the same length as side A in blue. And so two triangles are actually possible if you are given side B, side A, and angle A. You can see I've done some copy and pasting here. And this triangle that I'm pointing at with my cursor has, a side that's A and a side that's B and an angle that's A. And so does this one. Okay. But they're clearly not the same triangles. And so this is called the ambiguous case of the law of sines. There's two different triangles that exist given this information, angle A, and side B. Okay. And so back to that other document. If little a that they give you is between B sine A and B, then two triangles exist in this case. Okay, and so let's start with an example. And we're going to do this one down here. And so we have a 40-degree angle. You might notice that I'm drawing it the same way every time. And we have, this is A, side B is 30, and side A is 24, which, is less than 30. And so what we're saying here is that either one of these could be side A, because if I did calculate this height, this B sine A, I would find that B sine A, B was 30 and A was 40. So 30 times the sine of 40, okay, is 19.3. And so B sine A is 19.3. And little a was 24 and little b was 30. And so you can clearly see that little a is bigger than B sine A, but smaller than B. And so we have two triangles going here. And so we're going to label this to be B2 and this to be B1 and this to be C. Okay, and so we'll have a C1 and we'll have a C2. And so you go and you'll solve the first one exactly the way you would have solved it before. And so the first solution is actually the one that's A, and then B1, and then we're going to call it C1. And so you would have gotten this one, quite honestly, if you hadn't even thought about how many solutions you are going to have. And so we're here. We set up this proportion, and we'll say that, the sine of 40 over A, which is 24, equals the sine of B, and we're going to say B1, over 30. Okay, and so when I solve that, I'll take 30 times the sine of 40 and divide by 24. All right, so 30 times the sine of 40 divided by 24. I get this number, but remember I'm trying to find an angle. So I hit sine inverse, and I get 53.5 degrees. I'm going to need that number later, and so I'll store it as B. Okay, and then I'll go ahead and find C just as we had before. And so again, if you had never thought about any of this, you probably would have been doing this all along. And you get C1 to be 46.6 degrees. I'm going to store that as oh, Darren just messed up. I hit C when I meant to hit B, didn't I? Hang on. And so I didn't want that, team. I'm sorry. So I wanted 180 minus B minus 40, and that is 86.5. Okay. Now I'll store that one as C. Then, okay, then I've got those sides, and then I can find C1. And so the sine of C1 over C1 is equal to the sine of 40 over 24. Now, and so that's just a proportion situation. And so I'm going to take 24 times the sine of C, which I just stored, and then divide it by sine of 40. And so this completes our triangle. So it's 37.269. So that is the first solution, okay? I've got angle B1, I've got angle C1, and I've got side C. All right, now, here's the thing, folks, okay? I know that this video has been riveting, but here's where it gets serious. So we just found this angle B1. I know that this triangle is not one of them that we're trying to solve that I'm tracing with my fingers here, but I hope you would agree that that triangle, so B1, B2, C, is isosceles, which means that this angle is the same as that angle. Now, the one that we really would be interested in is this one right here, okay? Please notice that these two angles that I'm pointing at have to add up to 180. Therefore, this one and this one have to add up to 180, which means that B2 is equal to 180 minus B1. Okay, and so we're going to go solve this equation. All right, and so the second solution that we're interested in is this one that sort of looks like this. It was a 40-degree angle, and then we had a side that was 30 here, and then we had a side that's 24 here, and we called that B2. Okay, and so the beauty is that we already know angle B2. We said it was 180 minus B1, and so we have that number stored in our calculator, that one for B, and so we have 180 minus B is this number here, and so B2 is 126.5 degrees, and we'll store that. And we don't need the original B anymore, so we can just go ahead and store it as B. Okay, and so B2 is 126.5, and so C2 is 180 minus B minus 40, which was A, and so C2 is 13.5 degrees, and we'll store that guy as C. All right, now let's just take a look at the picture and make sure that makes sense. Does it look like B2 might be 126 degrees and C2 might be 13 degrees? I think it does. And so then we say that the sine of C2 over little c2 is equal to the sine of 40 over 24. Okay, and so side C2 is then 24 times the sine of C divided by the sine of 40. And so we get 8.694. Again, you have to store those values in your calculator if you'd like to get some right answers all the way through. Okay? All right. So that covers that case. It's also true that I didn't. There's yet another case of this where it's possible that when you draw this triangle, and if it's 30 degrees, and this is angle A, it's possible that the side they give you is exactly the one that makes it a right angle. Okay, and I've given you an example here. And so in this case, little a equals B sine A. And so in that case, there's one solution. This particular one that I've drawn is pretty fast because it's a 30, 60, 90 triangle. And we know about 30, 60, 90s. And so that makes that angle 60. And we know that that's 10, and we know that this one is 5 root 3. You could use the law of sines and stuff, but in the interest of time, since I gave you a nice one here, we're there. And so 5 root 3 is 8.660. Okay. All right. So I hope you've enjoyed this video. The beauty, of course, is that you can stop and rewind it if any of it got too fast. And thanks for listening. Bye-bye.